So we're going to keep looking at polynomial functions, and we're going to look at them from the graph and see if we can come up with what function we think it is. So starting with this one, you can see I have an x-intercept at -3, I have a y-intercept at -2, and I have another x-intercept at +2. So more than one polynomial would actually fit this graph, but we're going to decide which one it's going to be. So let's start off by looking at these x factors. So I have x plus 3 from the -3. I have x minus 2 from the +2. I also can see a 5. I didn't say that one earlier, so let's say that one. I have this 5 that's an intercept. So I started with putting on the intercepts. Now at the intercepts, I can see that this one is crossing at the 3. I can see it's touching at the 2, and then it's crossing again at the 5. So that tells me this 2 needs to have an even exponent. So let's put this multiplicity of 2 in there. That way it will touch there. The 3 and the -5, I could just leave those. I can just leave those as 1 because I can see it cross, so they need to have odd exponents. All right. So what else we have is this -2. So we want to finish this graph off by saying, well, there's probably some kind of leading coefficient, a, but we want to make sure that that a matches our graph. So if I plug in 0, remember I don't know a, but I have 0 plus 3, I have 0 minus 2 squared, and I have 0 minus 5, and that's supposed to get me -2, right? Because that's where it's supposed to touch the y-axis. So let's keep our a. I have 3, -2 squared is 4, and then I also have this -5. So if I multiply the 3 times 4 times -5, this is going to give me -60a is -2, right? So that's our idea, is I know when I multiply these out times a, I should get -2, so this is a is -2 over -60, which is 1 over 30. So now I have the function. The function is 1 over 30. It's x plus 3. It's x minus 2 squared. And it's x minus 5. So I can see all of my factors. I have the right leading coefficient. Let's try it again. So this one, I have -3 as an intercept. I have -1 as an intercept. And I have +2 as an intercept. This time it crossed at -3, it crossed at -1, and it also crossed at 2. So I have all odd multiplicities here. Way up here, I do also see a y-intercept at 6, so that'll be important when I'm trying to find the leading coefficient. All right, so let's start off by saying, what do I have? I have x plus 3, I have x plus 1, and I have x minus 2. I'm just going to leave those as multiplicity 1, so cross, cross, cross. And then I know there's supposed to be a leading coefficient. Okay, so let's try to find that leading coefficient. So I'm going to plug in 0. I have a, 0 plus 3, 0 plus 1, and 0 minus 2. That's supposed to give me 6 because that's my y-intercept. So let's simplify. I have a. 0 plus 3 is 3, 0 and 1 is 1, 0 and -2 is -2. So 3 times 1 times -2, that gives me -6a is 6. So it says a is 6 over -6, which is 1. Actually, -1, sorry. So this -1, well, that really helps because then that matches our graph, right? I can see it was going down on the right. Well, that's only going to happen if my leading coefficient is negative. So I needed that for it to match up. So here's my f of x. You can put a -1, or you can just say negative x plus 3 times x plus 1 times x minus 2. Same thing. But I needed that negative to make it go down on the right, which is going to make it go up on the left because I have this overall degree of 3 here. Okay, let's look at this one. So I can see at -3, it's going to cross. At -2, it's going to cross. At 3, it's crossing. At 4, it's crossing. So this is crossing, 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 crossing that's happening to this graph. So I had the x plus 3, I had x plus 2, I had x minus 3, I had x minus 4. So these are my 4 intercepts I can see on the x-axis. In crossing, I'm just going to put 1s again for all of those, keep it nice and easy. There's a leading coefficient. Hopefully you're thinking it's negative because it's going down on the right. And we need to find that leading coefficient. Okay, now we should know leading coefficient we're going to get by plugging in 0. So I have a 0 plus 3, 0 plus 2, 0 minus 3, and then 0 minus 4. That's supposed to give me, I can see down here, this is negative 3. Okay, so I have a times 3 times 2 times negative 3 times negative 4. That's supposed to be negative 3. So let's do 3 times 2 times negative 3 times negative 4. That gives me 72a is negative 3. Divide by 72. We can simplify that to negative 1 over 24. Again, we knew it was going to be negative, it was going down. So my f of x is negative 1 over 24, x plus 3, x plus 2, x minus 3, x minus 4. Okay, let's do it without a graph. So without the graph, I'm telling you I have zeros of 3, which has a multiplicity of 1. I have a 0 at negative 2, has a multiplicity of 2, and it has a y-intercept of 1. So kind of giving you the same information, but just in a different way. So having this 3 says x minus 3, the multiplicity of 1, there's my exponent. Negative 2 says x plus 2, the multiplicity is 2. I need to find that leading coefficient, just like I did before. And how I get there is by knowing the y-intercept. So let's plug in 0. So I have a times 0 minus 3, 0 plus 2 squared, and I know I'm supposed to get 1. So negative 3, 2 squared is 4. I have negative 12a is 1. A is negative 1 over 12. So I'm doing the same thing I was doing with the graphs, solving for the leading coefficient by using the intercept. So now I have negative 1 over 12, x minus 3, x plus 2 squared. Let's try it again. This one I said a little different. I have zeros of negative 2, 3, 4, and 1, and the degree is 4. So the degree being 4 and having 4 intercepts means they each have multiplicity 1. So I have f of x is equal to a, right, leading coefficient. I have x plus 2, I have x minus 3, I have x minus 4, and then x minus 1. So all multiplicity 1 because the degree overall was 4. Now this time I didn't give you the y-intercept. Instead I said if you plug in 5, you're going to get 28. So I told you a particular point on the function. So a, I have 5 plus 2, I have 5 minus 3, I have 5 minus 4, and then I have 5 minus 1, and that's supposed to be 28. So I took the x value, it becomes x all along. So 5 plus 2 is 7, 5 minus 3 is 2, 5 minus 4 is 1, and then 5 minus 1 is 4, and that's supposed to be 28. So we want to take this 7 times 2 times 1 times 4, and that gives us 56. So 56a is 28. Hopefully you see divide by 56. A is a half. Okay, now let's plug that back in. I have a half of x plus 2, x minus 3, x minus 4, x minus 1. One more different thing to do that I want to do for you is I want to take a function, f of x, that's x plus 3 squared, x minus 2, and then let's say like x minus 5, okay? So if I give you this function, you would know the x-intercepts, right? It would be negative 3, it would be 2, it would be 5, right? So no big deal, we know how to do this. So I want to ask you, what would be the x-intercepts if I made this instead f of x plus 7, right? If I took this function and then I transformed it, if I added 7, right, which actually we know moves the function to the left, where would these go now? So one way you could do that is you could just plug in x plus 7 to the function. So I would have x plus 7 plus 3. So think I did this x plus 7 and I added 3 and I'll square it. And then x plus 7, right, keep that, and do minus 2. And then x plus 7, think of that as a whole thing, and then minus 5. So I plugged x plus 7 in. So x plus 7 plus 3 is x plus 10. X plus 7 minus 2, 7 minus 2 is x plus 5. And then x plus 7 minus 5, 7 minus 5 is 2. So we could do it this way, where we could plug the x plus 7 in, and that would say, oh, I have negative 10, I have negative 5, and I have negative 2. The other thing you could do is think about x plus 7 is really moving it left 7. So if I do negative 3 minus 7, I get negative 10. If I do 2 minus 7, I get negative 5. If I do 5 minus 7, I get negative 2. So I like that duplicity there, that you have two different ways to do that. You could transform the whole function, left 7, and get the numbers, or you can plug the x plus 7 into the function, get new intercepts, and then find where they are as well. All right, hope that helps.